So let's continue our lesson with some definition of terms and conventions. Take note that in chemistry, energy that flows into the system is assigned a positive sign at yung energy that flows out of the system is assigned a negative sign. Kasi ang tinitingnan natin in terms of flow of energy is kung nadadagdagan ba yung energy ng system mo, which is positive, into the system, or nababawasan ba yung energy ng system mo, negative, nire-release dun sa ating surroundings. Kapag nagkakaroon ng change in energy, na-observe natin siya or na-measure natin siya in real life as one of two things or sometimes both. The first of which is what we call work or what we designate as W in calculation. Maybe you have encountered this in your physics. Take note that work has the formula of force times the distance kung saan yung object na in-applyan mo ng force ay nag-move. In chemistry, we have sort of a medyo varied units or varied quantities na minimeasure which will also arrive with unit similar to force times distance. Especially if we are working with gases, yung expansion at yung pagko-contract ng gases, iba yung mini-measure natin pero it's essentially the same thing. Wherein we will arrive with the unit Newton times meter or what we call the joule. Itong picture na to, medyo, ano to? Ano nangyayari? Mamaya, mas i-explain natin kung paano ba nare-represent ng work, nare-represent ng picture na to, yung work when it comes to our common systems in chemistry. What we would be discussing in detail muna ay yung other form of energy na na-observe natin, which is heat or dinedesignate natin siya as Q when we are using it in equations and calculations. So a simple example to explain which Q is positive, which Q is negative is yung physical changes or phase changes na ina-undergo ng water at different temperatures. So let's take a look at the one on the left. The state of the system before is this one. Tapos, magiging ito siya. So, from here to here, para ma-reach niya itong final state na to from this state, ano ang nangyari? Nabawasan yung heat ng system natin at na-release siya sa ating surroundings. Since ang reference natin ay yung system, in this case, it's the water, nabawasan yung heat, ibig sabihin, our Q for this example on the left is negative. Sa example naman on the right, the original state is this one. Meron tayong ice at yung final state niya ay ito kung saan puro liquid na lang tayo. Para mangyari yung transformation from this state to this state, kailangan mag-absorb or tumaas yung heat ng ating system para mag-melt yung ating ice. So, kumuha ng heat yung system natin from the surroundings at nadagdagan yung heat niya sa loob. Kaya naman, ang sign ng Q natin for this case is positive. Take note that for both cases, on the left and on the right, ang flow of heat natin ay from mainit to malamig. Okay? So, mali yata yung arrow ko. From mainit, the system, to malamig, the surroundings. Since mas mataas ang temperature ng system kesa sa surroundings, dito sa example natin on the left, heat would flow from the system to the surroundings or heat would flow outward. Dito naman sa right, since mas mataas or mas mainit, mas mataas ang temperature ng surroundings kesa sa system, heat would flow from the surroundings to our system so that when it reaches its equilibrium state, magkakaroon tayo ng equal temperature at para mangyari yun, kailangan dumagdag yung heat ng system compared to its previous state. So we have terms that we use to define kung yung flow ba ng heat during a physical or chemical change is into the system or out of the system. So let's take a look at the first example. Yung ating explosive combination of hydrogen gas and oxygen gas to form your water molecule. Imagine niyo kapag meron tayong binaburn na something, nare-release ba yung heat or naa-absorb ba yung heat? Kapag merong nagbo-burn na fuel or chemical, yung heat natin ay nare-release from the system to the surroundings. Teka ma'am, baka mag-violent reactions kayo. Bakit ma'am kapag magsisindi ako ng kandila, kailangan ko siyang lagyan ng lighted matchstick? Hindi ba kailangan ko mag-input ng heat para masunog yung kandila? At saka ma'am, kung nagre-release ng heat, bakit inad mo dun sa reaction as plus heat? Okay, first question muna. Bakit kailangan ko maglagay ng lighted matchstick sa kandila para umapoy siya? Hindi ba yun input of heat into the system? Okay, pag-aaralan natin to in detail pag umabot na tayo sa kinetics. Okay, next lesson pa yon. Pero, just to put it simply, kaya natin nilalagyan ng matchstick, lighted matchstick, yung kandila para umapoy kasi kailangan natin ng spark plug or pang jump start para mag-proceed yung reaction. Kapag napa-jump start na natin yung reaction, in this case, yung pagbo-burn ng hydrogen gas with oxygen gas, yung reaction ay magiging quote-unquote self-sustaining na at habang nagpo-proceed yung reaction, titignan natin kung nagre-release ba yung reaction na yon or nag-absorb ng energy. So kapag na-jump start na yung pag-burn ng hydrogen at oxygen, nagre-release na siya ng energy in the form of heat. Second question, ma'am, bakit plus heat yan kung nagre-release ng heat? Hindi ba kapag nagre-release ng heat, sulat natin, di ba pag release ng heat, you have a negative Q? Bakit plus yun? Okay. In this case, makakatulong siguro if we view this equation just like a math equation. So, gawin nating equal sign yan. Tapos, i-recall natin. Ano ulit yung system natin kapag meron tayong chemical reaction? Di ba yung mga reactants? Ngayon, titignan natin kung ano bang nangyayari sa heat in terms of if it is a reactant. Kasi yung titignan, since ang system natin ay reactants, kailangan nating malaman kung ano yung relationship nung flow nung heat sa reactants. Okay? So, paano natin gagawin yun? Imagine that you would transpose the heat from the product side to the reactant side. At according sa algebra, kapag nag-move ako ng isang positive na term to the other side, magre-reverse yung sign niya at magiging negative heat tayo. So, if in terms of the reactant side, we can see now that heat is subtracted from the reactants when you have the explosive combination of hydrogen gas and oxygen gas to produce your water. Another way of interpreting it is that since heat is on the product side of the equation, heat is a product of the reaction aside from yung ating mga chemical products, which is in this case, water. Etong mga reactions na to, yung mga feels hot reaction na tinatawag. Ma'am, akala ko ba nagre-release ng heat? Bakit feels hot? Di ba dapat nababawasan yung heat? Tandaan mo na ang ating system ay yung mga reactants lang. Ibig sabihin, ikaw ay part of the surroundings. So kapag nilapit mo yung kamay mo dun sa nasusunog na bagay, you feel hot because the heat is being transferred to the surroundings, which is you. So, you are not always the center of the universe. #atake. Okay? O, teka lang. Makakalimot tayo. Ano ba yung specific na tawag dito sa mga reactions na ganito? These types of reactions which release heat or transfer heat from the system to the surroundings are what we call exothermic processes or exothermic reactions. Again, an exothermic process occurs when heat is transferred from the system to the surroundings. At ang sign ng ating Q for an exothermic process is negative. Kung meron naman tayong mga feels hot reactions, syempre, kabaliktaran nun ay yung mga feels cold reactions. Baka or most probably ginawa nyo to in class, yung reaction of sodium bicarbonate and acetic acid to produce sodium acetate, water, and carbon dioxide. Very, very common chemical reaction. At pina-feel sa inyo kung ano yung nangyayari doon sa flask kapag nagpo-proceed yung reaction na yan. At if you would recall, malamig yung flask or malamig yung container ng ating chemical reaction habang nagpo-proceed yung reaction. Kaya naman siya ay feels cold reaction. Okay, so sa tingin nyo, saan ko i-add yung heat dito sa aking chemical equation? Do I add heat on the left side, on the reactant side? Or do I add heat on the product side or the right side? Kapag meron tayong mga feels cold reaction, the heat is added to the reactant side and ito yung mga tinatawag natin na endothermic reactions. An endothermic process occurs when heat is transferred from the surroundings into the system. So, dumadagdag yung heat ng system na ino-observe natin. O, baka malito-lito na naman tayo ha. Let me repeat that. Kaya siya feels cold ay dahil ikaw ay part ng surroundings. Yung kamay mo ay part ng surroundings at sa'yo nanggagaling yung heat na pumapasok dito sa ating chemical reaction. Ibig sabihin, dumadagdag yung heat ng ating mga reactants at nababawasan yung heat ng kamay mo kaya mukha siyang malamig. Malamig din yung flask kasi kasama dun sa reaction or kasama doon sa surroundings ay yung flask kaya nababawasan din siya ng heat dahil sa kanya nagdodraw ng heat yung ating mga reactants. Okay, ma'am, paano pag nilagyan ko ng thermometer yung loob ng aking reaction flask? Bakit bumababa yung temperature doon sa, yung temperature reading doon sa aking thermometer? Tandaan ninyo na yung thermometer ay kinukuha yung temperature ng ating liquid kasama yung water. And the water is actually a part of the surroundings. Okay? Hindi nyo nakukuha yung temperature ng ating molecules na nandoon sa inyong solution. Ang nakukuha nyong temperature ay yung temperature nung solvent, which is the water. Kaya naman, bumababa yung temperature ng water dahil part siya ng surroundings. Okay? So again, when something feels cold, the reaction or the change is endothermic. And when a reaction feels hot, the reaction is exothermic because you are a part of the surroundings. Okay, konting definitions na lang before we end this first part. So in thermodynamics, there are three types of systems that we can encounter. The first one is an open system. So habang nagpo-proceed yung change, you can exchange mass and energy with the surroundings. So pwedeng may gases na lumalabas or may nababawas na mga liquids or fluids. Pwede ring free din na mag-transfer ng heat from your system and your surroundings. You can also have a closed system which allows the transfer of energy but not the mass. So for example, you have a flask here which is covered so that no gases or liquids can escape while your change or your action is happening. And lastly, you can have an isolated system wherein no exchange of mass, may cover yung ating reaction vessel, or energy, insulated siya, can be done with the surroundings while everything is happening inside. Lastly, an important term that you have to understand is what we call state functions. These are properties that are determined by the state of the system regardless of how that condition was achieved. In thermodynamics kasi, pinag-aaralan natin yung changes sa state ng system defined by values of all relevant macroscopic properties. For example, composition, energy, temperature, pressure, volume, etc. etc. Bakit importante ito? Let's take a look at a certain example. Okay, kunwari ikaw si Little Red Riding Hood, tapos nandito yung bahay mo. Tapos, kailangan puntahan si grandma para dalhan siya ng soup. Kasi may sakit siya. Andito yung bahay ni grandma. Ano ibig sabihin ng state function? Marami kang pwedeng paths na daanan para makarating kay grandma. Pwede kang mag-hiking. Pwede kang mag-scooter sa highway. Or, pwede kang mag-rappelling, rock climbing. Okay? Lahat ng tatlong paths na yun, iba-iba yung total distance na tatahakin mo. Iba-iba yung effort na kailangan mong gawin. Iba-iba yung times na pwede mong i-take para makarating ka from your house to grandma's house. Okay? Pero, pag tinanong kita kung ano yung elevation ni grandma's house with respect to your house, no matter what path you take, whether it's the easy one or the difficult one, the elevation from your house to grandma's house will be the same. So, elevation is a state function and effort is not. Dito, siguro nung nagra-rock climbing ka, sobrang dami mong effort, mas kulada na si Little Red Riding Hood. Pero dito, dahil nagda-drive siya at medyo flat yung daan, chill lang si Little Red Riding Hood. Okay, bakit kailangan ko malaman kung ano yung mga state functions na yan? As you can see on the left, energy is also a state function. Ano namang use niyan sa buhay natin? Yun kasing mga chemical reactions, pwedeng same yung starting reactants ko at yung end products, pero iba-iba yung dadaanan kong path para makarating from point A reactants to point B products. Kahit gaano pa kahaba or kaiksi yung daanan kong path from reactants to products, yung change or amount of energy na kailangan ko to go from reactants to products ay same kahit pasikot-sikot pa akong magpunta from the reactants to the products. Parang si Little Red Riding Hood, kahit i-take niya yung pasikot-sikot na path or i-take niya yung mas diretsyo na path, yung elevation from her house to grandma's house will be the same. At magiging importante yan when we get to the next few lessons dahil minsan, mas madali na mas mahabang path yung kukunin mo for the same amount of energy but the least amount of effort. At makakatulong din yan doon sa mga ginagawa nating mga assumptions when we are calculating using these energy changes.